Hello, I'm Alex Gonzalez and this is my Lab 4. So in this lab we used Ohm's law and a virtual circuit program in order to show how different circuit elements affect the current and voltage throughout a circuit. So half of the lab focused on finding currents in a simple one-loop circuit with just a battery and a resistor, but the other half of the lab focused on a circuit that involved a capacitor and a light bulb getting charged by it. So the model that we used featured ideal components, so all the components that weren't resistors had zero resistance, and each value is going to be the correct value throughout. So unlike the real world where an ammeter probably has a small resistance and so does a wire, this lab did not feature that. And also resistors might not be totally accurate in the real world, but in this lab they are. So a few key takeaways of this lab. We were shown that in a one loop circuit the current is going to be the same at every point in the circuit. And we saw that even though they were ideal components in this lab, the calculated resistances of the resistors was a bit off. I think most of this has to come down to the fact that the ammeter only read to, I think, 3 digits, where if it read any further it probably would have found the correct value for the resistors. And we saw in the other half that discharging the capacitor actually takes more time than charging it. So the main purpose of this lab in the second half was to find RC, or the time component that it takes for the voltage drop over the capacitor to reach 1 over E of its original value. So the way we found this is we found the voltage drop at over a 20-second interval, and then we charted these as shown, and then we took a graph of the natural log of the voltage drop over the original voltage drop over the capacitor versus time. We then take the calculated slope of this graph and set that equal to -1 over RC, and by doing that we calculate RC, or the time constant, which is equal to 5.99 seconds, or just 6 seconds. And to just calculate it regularly in the circuit, we multiply the resistance times the capacitance, and that shows that it's 6 seconds as well. So here are the lab questions associated with the lab. What if you were going to do the lab in real life and used an actual ammeter instead of an ideal simulated ammeter? Most likely, because it has a resistance, the current throughout this loop would have been lower, because that in Ohm's law, current equals voltage over resistance, and because the resistance would have gotten higher, the current would have also gotten lower. And this is because, like I said earlier, an ammeter in real life is actually going to have a resistance, unlike in this lab where it had no resistance. And also, not discussed in the question, but the wires would have a small resistance which would affect it. And most likely the resistance values of the resistors would be slightly off of advertised, and maybe even the battery would be as well. And the last question to wrap up this lab is, if you were doing this in real life, how would it change? The capacitor would basically charge instantly, and unlike this lab where it charged in a few seconds.